Okay, let's work problem 21 on page 551. And I'll read the problem. It says a 20 ohm lamp and a 5 ohm lamp are connected in series and placed across a potential difference of 50 volts. And then what is A, the equivalent resistance of the circuit, B, the current in the circuit, C, the voltage drop across each lamp, and D, the power dissipated in each lamp. So here's what's given. We have a lamp, a 20 ohm lamp and a 5 ohm lamp are connected in series. So I'm just going to draw them as resistors because lamps are just resistors. And it just makes the drawing a lot easier. And they're connected in series. And this was given to be, delta V here is 50 volts. And the first lamp, we'll call that R1, is 20 ohms. And then R2 is 5 ohms. And what we want to find, A, the equivalent resistance of the circuit. Sometimes I call that the total resistance. And then B, the current in the circuit. C, the voltage drop across each lamp, and I'll call that delta V1 and delta V2. So the 1 and the 2 just represent the voltage drop across 1 and resistor 2. And then D, the power dissipated in each lamp. So power 1 and power 2. So you see the way I set that up. The 1 and the 2 refer to the resistor we're talking about. So let's solve. So for A, well, the total resistance is just R1 plus R2. So that's going to be equal to 20 plus 5 is 25 ohms. And part B, what is the total current? Or what is the current in the circuit? The current's the same everywhere. There's only one loop in the circuit. So the current's going to be the same. So I know that the total voltage is equal to I times the total resistance. So I will be equal to the total voltage divided by the total resistance. So 50 volts divided by the total resistance, which is 25 ohms. And remember, an ohm is a volt per amp. So that gives us, the current is 2 amps. And then part C, well, now we can figure out the volt. Now that we know what the current is, and we know what the resistances are, we can figure out what the voltage drops are. So delta V1 equals I times R1. Well, it's 2 amps for the whole circuit. And then this is 20 ohms. And just for fun, I'll remind myself that an ohm is a volt per amp. That gives me 40 volts equals delta V1. And then delta V2 is equal to IR2, which is 2 amps times R2, which is 5 ohms. And that's going to be 10 volts, which is delta V2. And the thing, look, 40 volts but 10 volts. That gives me 50 volts. So the voltage gain is indeed equal to the voltage drops. What does that mean? It means I did it right. Yay for me. Now power equals I times, P1 equals I times V1. So that's 2 amps. Well, that's a coulomb per second. Oops. And V1 is 40 volts. Well, that's a joule per coulomb is a volt. That cancels out, gives me a joule per second. That's a watt. So that's 80 watts is equal to P1. And then for P2, we do the same thing. We have the same current, but we only have 10 volts, 10 joules per coulomb. So that gives me 20 watts is equal to P2, which completes the problem. Any questions on how to do problem 21? Look good? Okay, that is all.